Hello, this is Mr. Stansbury. I'm going to take you through the 18D assignment. Okay, so we'll start here with number 1A. Find the chi-squared calc for the following contingency table. So for this one here, we just have 2 rows and 2 columns of data. We want just this stuff right here. That's, remember, these are the totals for each, for the finding the expected values. So again, chi-squared, we're just going to use the raw data. All right, so get our graphing calculator out here, and we're going to go into matrix. I'm going to go over to edit, and this one here is 2 rows by 2 columns, so 2 by 2, not 22 by 22, 22 by 2. Let's try that again. So we've got 2, let's get rid of that. Enter by 2, enter. There we go. All right, so now we can enter in this data here. So we've got 31, 22, 20, and 27. Okay. So once we have all of our data enter in, then this is a statistics unit. So we're going to push stats, and this is the chi-squared calculated test. So we're going to go over to test, and we have to go down until we find chi-squared, which is right here. Push enter, and we put our data into the observed into A. It will calculate the expected for us, but we just want to get down to calculate and push enter, and it gives us that our chi-squared value is 2.53. Okay, so this one here, we've got chi-squared equals 2.53. Okay. All right, let's try some more here. So for this one here, go back into matrix. We're going to edit, and your best bet is just to always use matrix A. Then you don't have to change anything in your calculation piece. So this is also, B is also a 2 by 2. So we'll do 28, 17, 52, and 41. Okay, so go back into stat. It's under chi-squared test. So there's our chi-squared test. Go down to calculate, and we got 0.495, so let's go with 0.5. So chi-squared equals 0.50. Okay. Okay. Next one here. We get our back into stat. Oops. Sorry, we're going to edit. And this one here. Oops, sorry. Matrix. Second matrix. Go over to edit. And this is 3 rows by 2 columns. So 3 enter, 2 enter. And we'll put our data in here. 11, 16, and 18, and then 25 and 12. Okay, so stat, test, go down to chi-squared, which is right there. Enter, enter, enter. Calculate, we got 4.30 for our chi-squared on that. All right, and then last one here. Excuse me, let's see, let's put in this data here. So second matrix, edit. This is 2 rows by 4 columns. So 2, enter, 4, enter. And then we'll put in our data, 31 and 22, 21 and 16, 23 and 19, 22 and 13 is all of our data. Okay, I'm just going to double check, make sure I got it all in right. Looks good. And we will go into stat, test, chi-squared test. All right, and we get 0.014. That is not, oh no, sorry, 10.53. That's not what we're supposed to get, so I messed something up in here. Let's take a look at our matrix here. Oops. Get matrix. We got to edit even to look and see what's in there. 31, 22, 21. Oh, there's a 2 down there. That was the problem. Okay, so 31, 22, 21, 16, 23, 19, 22. There's my mess up, and then 13. Okay, so now we can stat chi-squared test. All right. And that's what we're supposed to get, 0.731, or whatever we want to round it off to. It doesn't specify where to go to, so I'm going to go 3 significant digits, 0.731 for that. Okay, number 2 says now use a calculator to check your answer to question 1. That's what we just did. You can do this all by hand, but it is painful. So we are going to we're just going to keep it to the calculator on this one. Okay, find the degrees of freedom for the contingency tables of question 1. Okay, so easiest way here, let's see if I can show you this a better way. Try this. So degrees of freedom, take out 1 row, take out 1 column, and it's however many cells you have left. So when we do that, we just have 1 left. So degrees of freedom for number 1 is 1. Okay, so again we go back here, take out a row, take out a column. Oh, yeah, a row and a column, and we just have 1 left. So degrees of freedom on this one here is also 1. This one here, take out a row, take out a column, and we are left with 2. So degrees of freedom is 2 on this one. And then last one, take out a row, take out a column, count what we have left, and in this case, the degrees of freedom is 3. Okay? All right, let's move on to the next part here. Find the degrees of freedom of this one here. Okay, so let's do the same thing we did before. We're going to take out a row, and we're going to take out a column, and we are going to count what's left. So we have 1, 2, 3 rows left by 1, 2, 3, 4, 5, 6 columns. That's going to give us 18 total cells in here. So that's our degrees of freedom, is 18. All right. All right. Number 1 from 18D2. Random sample of people is taken to find if there's a relationship between smoking marijuana as a teenager and suffering schizophrenia within the next 15 years. The results are given in the table below. Okay, test at a 5% level whether there's a relationship between smoking marijuana as a teenager and suffering schizophrenia within the next 15 years. So let's use our little 6 steps to figuring out a chi-squared test. Okay, here's all of our steps for all of the chi-squared tests, but it's only asking us to test at a 5% level. Let's just do the whole thing. Let's make this work. Okay, so write the null hypothesis that they are independent. So step 1 here, we got HO. Our null hypothesis is that a relationship we're looking for smoking marijuana as a teenager and suffering schizophrenia are independent of each other. So smoking marijuana and suffering schizophrenia. I do not know how to spell that. Are independent of each other. Probably a better way to write that is smoking marijuana is, as a teenager, I'm just not going to write all that stuff down there, is independent of suffering schizophrenia. Okay, and then the alternate hypothesis, H1, is just going to be smoking marijuana is dependent on suffering schizophrenia later on in life. I really think we probably ought to write it the other way around. Suffering schizophrenia is dependent on smoking marijuana as a teen, because that's one is dependent on the other. So let's write it that way. Calculate our degrees of freedom, take out a row, take out a column, and we are left with 1. So our degrees of freedom is 1. Determine the significance level you are looking for, 3. They tell us right here at 5% level. So significance level is 15, oh, not 15, 5%. 5%. Okay. Next thing, write the rejection inequality. So that's going to be reject HO if, and then that's where we've got our chi-squared calculated is greater than our critical value. Okay, and we have enough information now to come up with our critical value, so let's look that up on our table. Okay, so here's our critical values table, right? So we have our degrees of freedom is 1, and our significance level is 5, so this is the critical value that we're looking for. So to insert that data into this rejection inequality, we're going to put 3.84 here. And then what we have to do is figure out what our chi-squared calculated is. So that's where we're going to want to get our calculator back and put our data in. All right, second matrix, go over to edit. And this is a 2 by 2. And let's put our data in, 58 and 73. And then 269 and 624. Okay, so we will go back into stat and we're going to calculate our chi-squared test. All right, so here's chi-squared test. We put our new data into A, calculate, and we get that our chi-squared is 10.53, we'll call it. Okay, so we've got 10.53. Okay, so 10.53 is greater than 3.84, so that means we are going to want to reject HO and therefore accept H1. So here's our info that we're going to keep, right? So officially 5 was this right here, our calculate chi-squared, and then plug into the rejection inequality and interpret results. So we would want to say we the rejection inequality is true, so we reject HO, HO, and therefore accept the alternate hypothesis, which is this right up here. Okay, so suffering schizophrenia is dependent on smoking marijuana as a teen, according to the data here. All right, moving on. Number 3 here. Table shows the way in which randomly chosen group intend to vote in the next election. Test at a 5% level whether there is any association between the age of a voter and the party that they wish to vote for. Okay, so just in the interest of time, when you actually go through and do this, you'll want to write the null hypothesis and alternate hypothesis. I'm just going to pause and write those down really quick. Okay, so here's our null hypothesis. The party one votes for is independent of the age of the voter, and then our alternate hypothesis, the party one votes for is dependent on the age of the voter. All right, Part 2, calculate the degrees of freedom. So cross out a row, cross out a column, and we're left with 2 cells there. So our degrees of freedom is not 1, but 2. Okay, determine the significance level that we are looking for. It says right up here at 5%. So the significance level is 5%. Okay. 4, write the rejection inequality. So that is right here, reject HO, reject our null hypothesis, HO, if, and then we have chi-squared calculated is greater than the critical value. Okay, so now we'll want to figure out what both of those are. Let's figure out our critical value by looking at our table. Here's our table. Our degrees of freedom is 2, and our significance level is 5%. So here's our critical value, 5.99. Right, and then now we're going to want to come up with our chi-squared calculation here. All right, so let's get our calculator back, and let's see. Let's put our data in. All right, so we're going to turn it on. Second matrix. Go over to edit. This is 2 rows by 3 columns. And let's put our data in. So we got 85, 95, and 131. Okay, and then 168, 197, and 173 is our data. So let's go back into stat, and we're going to do our chi-squared test. So I'll go down to C, chi-squared test, enter, 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 and our chi-squared is 8.58. So we got 8.58. Okay, so we are going to reject HO, our null hypothesis. Okay, so we're going to reject HO. And so therefore we're going to accept H1. So here's our H1. So that means since we rejected HO, the party one votes for is dependent on the age of the voter. Okay, depending on which book you have, the back will say, on some of the books will say that there is no association between age and the party to vote for, but according to our data here, they are dependent. So it does depend on the age. The party one votes for is dependent on the age of the voter. Okay? All right. Moving on to number 5. Okay, this contingencies table shows the responses of randomly chosen sample of 50-plus-year-olds to a survey dealing with people's weight and whether they have diabetes. Okay, so test at a 1% level whether there's a link between weight and suffering diabetes. So again, I'm just going to pause here and write the null hypothesis and the alternate hypothesis. Okay, so null hypothesis, suffering diabetes is independent of weight, and alternate hypothesis, suffering diabetes is dependent on weight. Okay. Part 2, calculate our degrees of freedom. If we take out a row and we take out a column, we are left with 3 pieces of data there. So degrees of freedom is 3. Okay. Determine the significance level we are looking for. Told us up here that it was 1% level. So significance level is 1%. Okay, write the rejection inequality. So reject the null hypothesis if, and I would highly suggest when you write this rejection inequality, instead of writing just the inequality, I would say reject HO if. It just makes it a lot easier to keep things straight when you're after you find your critical value and your chi-squared value. Okay, so if our chi-squared calc is greater than our critical value. Okay, so let's find our critical value. All right, degrees of freedom is 3, and that's 10%, 5%, 1%. So we are right here at 11.34 is our critical value. 11.34. And then now let's figure out our chi-squared value. Okay, so second matrix, go into edit. This is 2 rows by 4 columns, so 2 enter, 4 enter, and we'll put in our data. We got 11, 19, 21, 38, 79, 68, 74, and 53. Okay, to figure out what our chi-squared value is, stat, tests, go down to C for this calculator anyway. Yours might be different. Go down through to calculate, and we get chi-squared is 22.60. Okay, so this is true, so we reject HO, the null hypothesis, and we then accept the H1, the alternate hypothesis. So that means, according to this data, suffering diabetes is dependent on weight. Okay? All right, last one here. Number 6, following table is a result of major investigation considering 2 factors of intelligence level, IQ, and cigarette smoking. Test at a 1% level whether there's a link between intelligence level, IQ, and cigarette smoking. All right, so let's start off with number 1. We'll write the null hypothesis and the alternate hypothesis. Okay, so null hypothesis, intelligence level is independent of cigarette smoking. Alternate hypothesis, intelligence level is dependent on cigarette smoking. All right, number 2, calculate the degrees of freedom. Take out 1 row, take out 1 column, and we are left with these 6 cells here. So degrees of freedom is 6. Okay, and number 3, determine the significance level, 1% level. So significance level is 1%. Step 4, write our rejection inequality. So reject our null hypothesis if we have chi-squared calculated is greater than our critical value. Okay, so let's figure out our critical value first. Okay, so our significance level is 1 and our degrees of freedom is 6. So here's our degrees of freedom is 6. Significance level 16.81, that's the 1%. So here's our 16.81. And then now we're going to want to figure out what our chi-squared calculated is. So let's go second matrix, go over to edit. And this is 2 rows. Let's see, no, wait, that is 3 rows, right? We've got 3 rows. Just want to make sure that was not the totals, but it's not. So we are 3 rows by 4 columns. Okay, and now we will go through and enter all of our data in. I'm going to pause for this for a second. Okay, here's all of our data entered in. Let's calculate it. Stat, chi-squared test. Go down to chi-squared test, enter, 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 and enter. And our chi-squared value is 12.598, so let's go with 12.60. And just kind of as a side note, it'll always give you the degrees of freedom as well in there, which we had already figured out. But we got 12.60. Okay, 12.60 is not greater than 16.81, so we are not going to reject HO, so that means we are going to accept HO, which is our null hypothesis. So that means that intelligence level is independent of cigarette smoking. Okay? Okay, that's all there is for this assignment here. If you have any other questions, please feel free to ask in class. Thanks.